Okay, we want to look at 14.5 now. Conservative forces. What's a conservative force? And potential energy. And we'll see how these are related to each other. Okay, so in this little paragraph over here, they speak about what they try to define a conservative force. Sorry, I don't mean they try. They do define a conservative force. It is the work of a conservative force is independent of the path. Okay, where have you seen that? We've seen that with weight, for example. If you have a mass and you lift it up like this, then you go down and you go up and you go there, and you put the box, this mass, on a shelf, then the work done by the weight, which is a conservative force, is independent of this path. It only depends on the initial and final positions. Okay, if you recall, so there's the weight. It doesn't, the work of the weight is not a function of the total path. It's a function of the initial and final positions. Okay, so that is absolutely correct. Obviously, who am I to say anything about that? But I just feel that something more important, a more important characteristic will help us understand a conservative force. A conservative force has the ability to conserve and to store energy. Right? That to me, I mean, you know, you could argue with me, and the more intelligent people can argue with me. That's fine. But it is a force that can store energy. So gravity or weight is able to store energy. So you've taken this mass, okay, and we've raised it up. But now what's happened is we've increased the energy, the potential energy. Okay, in a sense, we've stored energy in this gravitational field. And so if we let it go, this weight will be able to do positive work. So it is a conservative force is able to store energy so that we can gain this energy back. Similarly with a spring, okay, if there's your spring and you compress it, okay, then the spring force, which is acting in that direction, right, there's your spring force. What you've done now is you have conserved energy, you've stored energy in the spring, which can then be used as positive work. Okay? So I hope this hasn't confused everyone. A non-conservative force, okay, let's see here. A non-conservative force is a force that dissipates energy. We lose the energy to heat mainly. We can't get that energy back. A conservative force, you store it so that you can recover the energy. You can recover that energy. But a non-conservative force, we lose that energy mainly due to heat. And it is dependent on the path. Okay, the work of that force is dependent on the path. All right? So, let's see here. So now you can see how conservative forces and potential energy are related. Potential energy is the energy that comes from the position. Okay, so if you raise this box up higher, then it has a higher potential energy. There's more energy stored. If you compress the spring, it is energy that is now stored based on its position. Okay? And also another way of looking at this is the potential energy is the amount of work a conservative force, right, like weight or spring force, will do when moving to the datum. Okay? So those are the important things. I hope I didn't confuse you too much. See you in the next one.